Now, as we continue solving systems of equations, now we're going to focus on doing it algebraically. Graphically is one way, and then algebraically. And there's going to be two methods that we do algebraically, and one would be substitution, and the other would be using elimination. In the end, really what are we doing? We're solving for our variables independently. Now, in doing so for the substitution method, let me see here, one algebraic method to solve the system of equations is the process of substitution, in which one equation is solved for one variable in terms of the other. So what would that be here? Solve at least one equation for one of the variables, substitute the resulting expression from step one into the other equation, and then solve. You got to remember, we can only solve for one variable at a time. So if we look at this, we have this system working together, and they're saying solve one of the equations for one variable. So if you look, I could subtract 2y from both sides, and then all of a sudden x is equal to negative 2y minus 12, and that's what you see down here. So I have now solved that equation for one variable. So that is step one. Step two, they're saying go back, and where I had x, I am going to plug in that information because it is the equivalent. It is equal. And that's what they did. They said, okay, we have 8x minus 3y equals negative 1, and then 8 times what x equals this, so therefore we can substitute it. Then they had to do the distributive property, so we ended up with negative 16y minus 96 minus 3y is equal to negative 1. Combining like terms, we have 13y. I think that's wrong. I think that is negative 19y, right? Minus 96 is equal to 95, and then ended up dividing both sides by 19. Sorry, negative 19. And then y is going to be equal to negative 5. And that is step two, where we substitute it back into the expression and came up with y is negative 5. So now that we know what y is, we can substitute that back in to one of our expressions, and we can come up with the value of x. So we found out that we have x is negative 2 and y is negative 5. In substitution, we have two expressions or two equations working together. We have to isolate one for a variable and then substitute that in, because we cannot solve for two variables at a time. So that's why we solved for x in terms of y, because now we only have the y variable in our system or in our equation. So we can now solve for y. Once we solve for y, then we can turn around and put it back in and solve for x. So that is the result of substitution. So here, again, I will just say we want to solve one of these equations for a variable, and since y is by itself, that does make it easy. You can simply add 5x to both sides, and we'd see that y is then going to be equal to 5x minus 3. And now you can substitute in 5x minus 3 for that y, and then use your mathematical operations and isolate and find out what y is equal to. So when I plug those back in, or when I plug in the value of y into my equation, I have 3x minus 8 times 5x plus 5x minus 3 is equal to 24. When you do your distributive property, you end up with negative 40x plus 24. Doing two steps here, subtracting 24 from both sides, right, because I want to make this 0. And then I'm combining like terms here, which would give me negative 40 plus 3 is negative 37x. So negative 37x is equal to 0. And then we know then that if you divide by negative 37 on both sides, x is going to be equal to 0. So we found the value of x. And then they said, now that you have x, plug it back in, and we have negative 5 times x, or negative 5 times 0, plus y is equal to negative 3. So 0 So y is equal to negative 3. Y is equal to negative 3. If you plug those two back in, you can check your answers and you'll find they're correct, because here, if this would be 3 times 0 and minus 8 times negative 3, which equals 24, and yes, 24 equals 24. So you can check them and verify that they are accurate. Substitute when there is not exactly one solution. Well, let's see what that means. Use substitution to solve. So look, they've already identified one of the variables, so we can substitute that back in right here. So we take and we substitute the value of y in, and that's what they've done. They've taken the equation and they said 2.5 times 2x minus 11, did the distributive property, that became 5x minus, looks like 27.5. This became 0, and then we have, technically, I have another typo there, minus 27.5 does not equal minus 15. So that is a false statement. So therefore, there is no solution to this system. And so if there's no solution, if I went ahead and took that first equation and I converted it into slope-intercept form, and in doing so, I was able to determine that if I rewrote this into slope-intercept form, it would be y equals 2x minus 6, and sure enough, they have the same slope. So yeah, there would be no solution because they're parallel. So tying those understandings together here. Applying the substitution method. Now, creating a system can be challenging, but Mrs. Washington is preparing a hydrochloric acid solution. She will need 300 milligrams. Okay, 300 milligrams, and she wants 5% solution for her class to use in the lab. If she has 3.5 solution and a 7% solution, how much of each solution should she use in order to make the solution? Well, think of it this way. We have two solutions. We have an X and a Y solution. We know we want a total of 300 milliliters. And so if we have this solution, the 3.5%, so is 0.035 X plus the 7%, 0.07 Y, is equal to, remember that solution we want to have is going to be 0.05% times the 300 milliliters. We don't know how much of the two other hydrochloric acids we're going to use. We don't know how much, but we know we want the result to be 300. So they did some substitution. They solved for X, which is X equals negative Y plus 300, and then they turned around and substituted it in here for X, did the distributive property, came up with this, once they did the distributive property, they combined like terms, and they found out that Y is approximately 128.57. Okay, if Y is approximately 128.57, we should be able to plug that back into our original equation and come up with an approximate value of X. And in doing so, they said that once we do that, then X is approximately 171.43 milliliters. So that's my system, my X and my Y. So that is the amount of hydrochloric acid we are going to use for our other two solutions. Now, that is using substitution. When we use elimination is where we will, let's just see. Multiply one or both of the equations by a number to result in the two equations that contain opposite or equal terms. Well, let's back up. Using elimination, the process of using addition or subtraction to eliminate one of the variables. So we will manipulate our equations to where as we combine them, we eliminate a variable. And that's what they mean manipulate. We're going to multiply the equations by values that will ultimately eliminate them, and then add and subtract the equations to eliminate one variable. So here we go. Looking at this, we are going to basically combine the two equations. So we combine down. we're going to combine like terms. But if I do this now, I don't eliminate a variable. All I do is get a very large variable number. But what I can do is I can take one of these lines and I can multiply by -1. That's okay, as long as you multiply everything by -1, both sides of the equation, we maintain the equality. And in doing so, this becomes a positive, this becomes a positive, and this becomes a positive. So now when you go to do your combination, right, when you combine your two lines, when I combine down, 4x plus or minus 2x is going to give me 2x. Then I have minus 9y plus 9y. That now disappears, right? It became 0. And then negative 25 plus 23 is going to be -2. Therein lies the add and subtract the equations, eliminating one variable. That's what we just did. We eliminated the y. Now, once we find out what that variable is equal to, of course, we divide both sides by the coefficient, and then x is -1. Just plug that back into our original equation. X is going to be -1, and we multiply and simplify, and we found out that y simplifies down to 3. So the solution using elimination is -1, 3. Okay, so looking at that, those are the processes, and I guess I could have written this in 4x, 9y, 23. Okay, so using this elimination, okay, so multiplying both equations before the elimination method. Now, in this case, I can't just multiply by a positive or negative, right? They're not the same values, but I can go with a least common multiple, to where I can get to that position. So what they're trying to do is we are going to eliminate the x values in their example, and what is the least common multiple that 2 and 3 have, and the least common number that is multiples of 2 or 3. And what they're saying is they're both divisible. 6 is divisible by both of those, right? So I know that 2 times 3 is going to give me 6, and then I would have to multiply 3 times 2, and that would give me 6. But remember, it has to be an opposite sign. So what they want to do then is I would just say right here, let's multiply by a -2. Okay, and we would then result with distributing, right? 3 times that, we get 6x plus 15y is equal to 3. When we distribute the -2, we get -6x plus 8y is equal to 20. Now, when we combine downward, right, when we combine our two equations, we ended up eliminating our x value. So we have what would be 23y is equal to 23, dividing both sides by 23, and then y is equal to 1. Okay, what they did was a little bit different, but not unusual compared to what we just did. So they subtracted something like that. Okay, but they ended up with the same answer. 23y is equal to 23, and then y is equal to 1. Plug that back in. Original equation, y. So as we multiply across, simplify, and then 2x is equal to -4 divided by 2, and x is -2. So our solution was going to be 1 and -2. So that was, for this equation, we had to manipulate, or for this system, we had to manipulate both equations to eliminate a variable. Okay, and eliminating where there's not exactly one solution. Now, you may again find out that we have parallel lines, and if we have parallel lines, they're not going to be a solution. But here they said we can manipulate this one by multiplying by a -3, because that would give me a -18 and a +18. That's and then I would have -21 and a +21, which is going to actually cancel out. And it turns out that my solution or the answer that I just came up with is 0 is equal to 8. But we know that those two things don't equal, so therefore there is no solution. And it turns out, if we went back and checked it, sure enough, that would be a parallel line. And that is working with substitution and elimination to solve my systems algebraically. So again, we have 3 methods to solve. Each one has its own value, and understanding the 3 methods allow you to pick the easiest method each time to solve. So that is the purpose of our practice.